If you ask me who my favorite Marvel superhero is, the answer is pretty obvious. It's Iron Man.
Hold on!
I'm the best.
And yeah, of course, it's because behind all that armor, there's Tony Stark, who...
Genius, billionaire, playboy, philanthropist.
The combination of him being a total badass, crazy smart, advanced tech, plus those iconic cinematic suit-up scenes, it just makes Iron Man look insanely cool. But in this video, we're not just talking about how cool Iron Man looks. We're also talking about the technologies Tony Stark created. And the first one we're diving into is literally the heart of Tony Stark and Iron Man himself. That weird and glowing thing sitting in his chest. What's interesting is, in the real world, we know this kind of technology as a fusion reactor. And fusion reactors aren't fiction, guys. This is a real future energy concept. Something that scientists are genuinely trying to build right now through a massive project called ITER, the International Thermonuclear Experimental Reactor. This super mega-scale project is currently being built in France, and it involves 35 countries working together, including the United States, China, Russia, and Japan. And the goal is actually pretty simple: to create an artificial sun here on Earth and provide extremely cheap electricity for humanity. Because in theory, with fusion technology, a single glass of water could generate enough energy to power one person for their entire lifetime.
1 pound of fusion fuel would produce 40 million kilowatt hours of electricity.
So, what do Iron Man, an artificial sun, and cheap electricity have to do with each other? Let's talk about it. Alright, let's rewind and start from the very beginning of Iron Man. Back to the cave, the place where Tony Stark first builds his armor, and that weird glowing thing in his chest. We all know that the story of Iron Man starts when Tony Stark gets kidnapped by a terrorist group called the 10 Rings. During the attack, a piece of shrapnel from a bomb ends up lodged dangerously close to his heart. Luckily, there's Yinsen in that cave, a doctor who implants an electromagnet into Tony's chest to keep that shrapnel from sliding in and stabbing his heart. Trapped in that cramped and suffocating cave, instead of doing what the 10 Rings want, which is building them a missile, Tony does something else entirely. He builds this. A small, strange device that saves his life and ends up becoming the heart of Iron Man himself.
That doesn't look like a Jericho missile.
That's because it's a miniaturized arc reactor.
Yup, in the Marvel story, this thing is called the Arc Reactor. It's basically a fictional and miniaturized version of a real-world fusion reactor. So, what is a fusion reactor? And this is where things get interesting, because fusion reactors aren't just a fantasy, it's real technology. And building one has been one of the biggest ambitions in human history. That's why in Iron Man, Tony Stark's mini fusion reactor gets snatched by Obadiah Stane until they start whooping ass. To make this story more interesting, we need to rewind about 100 years, back to the moment when this whole idea was first born. Do you remember Arthur Eddington? He's the scientist we briefly mentioned in that Einstein relativity video, the guy who helped prove Einstein's theory by observing a solar eclipse.
Just as Dr. Einstein predicted.
But here's the part most people don't realize. Arthur Eddington also played a huge role in the birth of the fusion idea itself. In 1920, through a journal he published called The Internal Constitution of the Stars, Eddington made a prediction that sounded completely insane at the time. He suggested that the energy inside stars comes from nuclear reactions, where hydrogen atoms at the core of a star fuse together, turn into helium, and release an enormous amount of energy in the process.
But in the 1920s, astronomers changed all this. They told us that it was nuclear energy that fired the sun and stars. Our sun is really a star, not just an ordinary furnace sending out light and heat, but a huge nuclear furnace that will burn and produce great amounts of radiant energy for millions and millions of years.
Back then, this was still just theory. There were no experiments, no reactors. Even the concept of nuclear physics was still extremely young. But from that idea alone, something big clicked. Scientists began to realize that fusing atomic nuclei could be the most powerful energy source in the universe. And that idea, atoms combining and releasing energy, is what we now call nuclear fusion. But at that point, all of it just lived on paper. Nobody knew if this reaction could actually be recreated here on Earth. Until the early 1950s. That's when humans tried fusion for the first time. Not in a reactor, but as a weapon.
This is the first full-scale test of a hydrogen device. If the reaction goes, we're in the thermonuclear era.
Because in 1952, the United States carried out the world's first hydrogen bomb test, called Ivy Mike. The test was carried out at Eniwetok Atoll in the middle of the Pacific Ocean. And the result? It worked. Fusion really happened. Hydrogen atoms were forced to fuse together, energy was released, and the power was far greater than any atomic bomb before it. But there was one massive problem. This fusion couldn't be controlled. What was created wasn't an energy source, it was a gigantic explosion that could only exist as a weapon. From that moment on, the world realized something crucial. Nuclear fusion is possible, but taming it is insanely difficult. Once the United States proved that fusion actually worked, other countries started racing to turn it into something useful. Not fusion that explodes, but fusion that's stable, controlled, and usable as a source of energy. That's where different fusion reactor concepts began to appear. The Soviets introduced the tokamak, the United States developed the stellarator, and many other approaches started being tested. And the imaginary version of a fusion reactor is the arc reactor that Tony Stark builds in the cave, like we mentioned earlier. Of course, a fusion reactor which is small enough to sit in someone's chest is pure fiction, at least as of 2026. Because in the real world, fusion reactors are incredibly complex and absolutely massive in size. But interestingly, there's one theory people often consider the closest thing to Tony Stark's arc reactor. We will get to that near the end. For now, let's break down what fusion reactors actually look like in the real world, and why scientists are so obsessed with making this technology finally work. So let's break this down in a simple way. Nuclear fusion is a process where the nuclei of hydrogen atoms combine to form a heavier atomic nucleus called helium. When that happens, something weird occurs. A tiny bit of mass just disappears. And according to Einstein, that missing mass doesn't vanish. It turns into energy, a lot of energy.
Here are 2 gallons of water. There's a little less than 1/100th of an ounce of heavy hydrogen in here, costing only a few cents to extract it from the water. Fusion reactions occurring in that quantity of fuel would produce the same heat energy as the combustion of 2 tons of coal, or the burning of 300 gallons of gasoline. 1 pound of fusion fuel would produce 40 million kilowatt hours of electricity, enough electricity for 20,000 people for a year.
And this exact process is what's happening inside the sun right now. That's the reason the sun can keep burning for billions of years without running out of fuel. It's not just a fire, it's fusion. So yeah, fusion reactions are really just us trying to copy how the sun makes energy. The problem is that fusion doesn't happen easily. The nuclei of atoms all carry positive charges, which means they naturally repel each other. To make them stick together and combine, extremely intense conditions are required. Inside the sun, those conditions occur naturally because its gravity is incredibly strong. But here on Earth, we don't have gravity anywhere near that level. That's why the only way to fuse the nuclei of atoms is by recreating those extreme conditions using fusion reactor technology. And that leads to the obvious question, do we actually have that technology right now? Here's the bad news. We understand the theory, the math works, the physics checks out, but building a real fusion reactor is unbelievably hard. Because when you really think about it, a fusion reactor is basically our attempt to build a tiny artificial sun here on Earth.
Doctor, we have a successful fusion reaction.
And yup, that turns out to be way harder than it sounds. Because of how insanely difficult fusion is, this is what eventually pushed 35 countries, including the US, China, Russia, and Japan, to come together and build one of the most ambitious mega projects humanity has ever attempted. A nuclear fusion reactor project called ITER, the International Thermonuclear Experimental Reactor. This massive project is being built in Cadarache, France, and it's expected to cost well over $50 billion. That's a crazy project, right? Now, let's quickly break down how this reactor is actually supposed to work. The fusion reactor in the ITER project uses a design called a tokamak. And what is a tokamak? A tokamak is a fusion reactor concept that is shaped like a giant donut. And yeah, you've actually seen this shape before in Iron Man. Inside a tokamak fusion reactor, hydrogen gas will be heated to around 150 million degrees Celsius. It's 10 times hotter than the core of the sun. At temperatures that extreme, hydrogen stops behaving like a normal gas and turns into plasma.
Now, when running, this plasma can reach the incredible temperature of 150 million degrees. Large magnets in the wall of the tokamak contain the plasma and stop it from touching the sides where it can cool down.
This extremely hot plasma has to be carefully controlled. It can't touch the reactor walls, because once it does, the reactor gets damaged and the plasma starts cooling down. So to prevent that, the plasma is trapped using extremely powerful magnetic fields. These magnetic fields force the plasma to spiral around the donut-shaped tokamak, keeping it suspended in the center of the reactor without touching anything. If those conditions can be maintained, the nuclei of hydrogen atoms collide often enough for fusion reactions to finally happen. When fusion occurs, two or more nuclei of hydrogen combine to form helium, and from that process, a massive amount of energy is released. That energy is then expected to be used to heat water, produce steam, and spin turbines, and that's how electricity would be generated.
And the hope is that this energy can one day be used to heat up water, turn it into steam, to drive a turbine and generate electricity.
And that's basically how the ITER fusion reactor is supposed to work. From the very beginning, ITER was never meant to be a fast project. This is one of the most complex science projects humanity has ever attempted, so it was always going to take a long time. The idea for ITER first appeared back in the late 1980s, but actual construction didn't really begin until around 2010. Originally, ITER was expected to achieve its first plasma around 2025, but due to massive technical challenges, that target has now been pushed back to the early 2030s. Will this insanely ambitious project actually work? Well, I guess we'll find out in about 5 years. But wait, if real-world fusion reactors have to be that big, that hot, and that complicated, then where did the idea of Tony Stark's tiny fusion reactor even come from? The answer takes us to a controversial concept known as cold fusion. Cold fusion is the idea that fusion reactions could happen without extreme temperatures, not hundreds of millions of degrees, but at something like room temperature. And if that were true, the implications would be insane. Fusion reactors wouldn't need to be massive, they wouldn't need giant magnets, and in theory, they could be made as a small and compact reactor, kind of like the Arc Reactor sitting in Tony Stark's chest. This idea first shocked the world back in 1989, when two scientists, Martin Fleischmann and Stanley Pons, claimed they had observed fusion reactions while experimenting with palladium. They reported excess energy that couldn't be explained by normal chemical reactions. But the problem is, when other scientists tried to repeat the experiment, the results weren't consistent. Most attempts failed to reproduce the same effect. Eventually, cold fusion was considered scientifically unproven, not because the idea was stupid, but because it's hard to prove. That's why, even today, cold fusion sits in this gray zone between speculative science and futuristic wishful thinking. But controversy aside, cold fusion is still the concept that comes closest to the Arc Reactor. Because even in the story itself, Tony Stark also made it from palladium.
That's palladium, 0.15 grams.
And so far, the only person who's ever managed to build a fusion reactor and actually harvest energy from it is just Tony Stark. And obviously, that's because he is
Genius, billionaire, playboy, philanthropist.
By the time we get to Iron Man 2, Tony Stark starts getting poisoned by the palladium itself.
Blood toxicity, 24%.
So what does he do? He creates an entirely new element to replace palladium as his power source.
Congratulations, sir. You have created a new element.
Wait, what? What element is that? And how does that new shit even work? Well, we'll break down that new element in the next video. For now, what matters is that you understand what nuclear fusion is. You understand how fusion reactors work. And you also understand that Tony Stark is
Genius, billionaire, playboy, philanthropist.